everyone. Today we will be looking at how do you identify similar solids. So in previous lessons we've learned that solids are just three-dimensional figures that have a volume. They're solid. So for example, our sphere, right? This is a three-dimensional solid. It is solid. And we have a cylinder, three-dimensional, right? We're going to be looking to see, are these two things similar? Well, right away you can tell that they're not because one is a sphere and one is a cylinder. But let's say that I have two spheres. Okay, so let's say I have this sphere right here and I have this sphere. We would be looking to see, are these two things proportional? And do they have similar dimensions? Ooh. So that is the idea of today's lesson. So first of all, we need to talk about what is a similar solid. So as the definition of a similar solid is similar solid. Oh my goodness. Okay, a similar solid. These are solids that have the same shape. And their dimensions are proportional. Dimensions are proportional. And you probably remember the word proportional from a few lessons ago when we looked at dimension or proportional relationships, and that was comparing the change between two fractions. So when we're looking at similar solids, we're going to be comparing the shape, so same shape, and proportional dimensions. So we're going to be creating fractions and seeing, do they have the same change between the two of them? So let's go ahead and look at our first example. All right, in our first example, we have we're going to have two solids. And our job is to figure out, are these solids similar? So our first solid is cylinder A. Cylinder A looks like this. And in cylinder A, it has a height of 4 meters and it has a radius of 6 meters. Okay, so we have a height of 4 and a radius of 6. We're going to be comparing this to cylinder B, and cylinder B is a little bit shorter and just a little bit smaller of a radius. So the radius on this one is 5 meters and the height is 3 meters. So our job is to compare cylinder B to cylinder A. All right, and how do we do that? Well, we're going to do that by looking at their dimensions. So you can tell in both of these they have a height and they have a radius. So we're first going to go ahead and look at their height. So let's look at the height of A. So the height of cylinder A is equal to 4. The height of cylinder B is 3. So we have a fraction of 4 over 3. the next dimension that we're going to be looking at is the radius. So when we're looking at cylinder A, we're looking at the radius of A, and the radius of A is equal to 6, and the radius of B is equal to 5. So when we're looking at these two fractions, we have a fraction of 4 over 3 compared to 6 over 5. Our job is to see, do they have a similar change between the two fractions? Do I multiply by the same thing on the top as I do on the bottom? So to get from 4 to 6, I can use my calculator and I can just divide backwards. So we're just going to divide backwards. 6 divided by 4, and that gives me a total of 1.5. So 4 times 1.5 gives me 6. Let's check the one on the bottom now. So the one on the bottom says 5 divided by 3, and that gives me a multiplier of times 1.6 repeating. So because the proportion of this relationship here is 1.5 over 1.6, this is said to be not proportional, which means that these are not similar. They do not have similar dimensions. So these two cylinders here are not proportional, and they are not similar. But let's look at cylinder A again, and now we're going to compare it to a second cylinder, cylinder C. So example B, we're going to use the same cylinder A. It has a radius of 6 meters and a height of 4 meters. And the next cylinder that we're looking at is cylinder C, cylinder C. And cylinder C, ooh, it's a little bit bigger. Cylinder C has a radius of 7.5 meters, and it has a height of 5 meters. So okay, so our job is to check both of these and to now see if they are similar. So our first step is going to be to look at their height. They both have a height, so we're going to check their height. So height of A is equal to 4. And the height of B is equal to 5. Now we're going to check out the radius. So the radius of A is equal to 6. And the radius of C, oh, why do I keep putting B? This should be a C. Sorry. And the radius of C, example C, is 7.5. So now what we're going to do is we're going to compare, is this fraction proportionate to this one? Do they have the same change? So let's check this out. So I'm comparing 4 over 5 to 6 over 7.5. Okay, up above, I know that I went from 4 to 6. It was times 1.5. So on the bottom, am I multiplying by 1.5? So let's pull up our calculator one more time. And let's check this out. I have 7.5, and I want to divide that by 5 so I see what I multiplied by. And it looks like I multiplied by 1.5. So this means that my proportion, or the change, is 1 over 5 out of 1 over 5, which means that, yes, these are similar because their proportions are the same. So cylinder A and cylinder C are both proportionate. They both are similar solids. Even though they look different, they have different sizes and different dimensions, they're similar because the change between them increases at the same rate. Okay, let's go ahead and do another one, and this time we're going to look at a cube or a rectangle prism. Okay, so we're going to have rectangular prism A and rectangular prism B, and then I'm going to give you a try it. So we have prism A. All right, rectangular prism A. It has a should draw this taller. Let me draw this one taller, sorry. Okay, so rectangular prism A is a little bit taller than what I had drawn, and it looks like this, and we connect the lines. There we go. Okay, it has 4 feet. It has 4 feet and a height of 8 feet. Okay, now we're going to compare this to prism B. So prism B. And prism B is a little bit different. Okay, so the length in the front is 3 feet by 3 feet by 6 feet. So our job is to compare these different dimensions. So first of all, let's look at the length. So the length on this one, length of A is 4 over the length of B, which is 3 feet. That is one fraction. So this fraction is 4 over 3. Our next one is 3 and 4 again. So we have a width of A, which is 4, over the width of B, which is 3. So we have 4 over 3 and 4 over 3. Both of those are already similar, right? They are very similar in that they have the same fraction. So we're just multiplying by 1 there. So let's check now. Let's check the height. So now we're going to look at the height. The height of A is 8, and the height of B is 6. Okay, so our job is going to be to compare the dimensions of these two prisms. When we're comparing, you can see that this is 4 over 3, the width is 4 over 3, and we can reduce this fraction here down by dividing by 2 over 2, and that will give us 4 over 3. So by simplifying this fraction, we get 4 over 3. So all of these are 4 over 3, which means that they have the same proportional relationship. So with these two prisms, we have similar solids. So these are similar. Same proportion. And similar solids. Okay, it is your turn now to do a try it. And in your try it today, I'm going to actually have you work on another cylinder, and you're going to compare that cylinder back to cylinder A. So going back to that first example there, and so here is your try it today. Try it number 1. We have cylinder A again, and cylinder A is 6 meters. The height of cylinder A is 4 meters. And then you have cylinder B. What color haven't I used yet? So cylinder B and cylinder D has an example or radius of 7 meters, 7.5 meters, height of 4.5. So we've got 7.5 meters on the height. This height here is 4.5 meters. Okay, it is your job now to tell me, are these two similar solids? They look different, their dimensions are different, but is their change the same? All right, so go ahead and hit pause right now so you don't hear me solving, and then come on back. So first, I'm going to compare their heights. So I'm going to look at their heights. Their height is of A. So the height of A is 4, and the height of D is 4.5. Then I'm going to look at the radius. So the radius of A is 6, and the radius of D is 7.5. So now I want to look and compare these two fractions. I have 4 and is equal to 6 over 7.5. Do I multiply by the same thing both times? Okay, so I believe that 4 times 1.5 is going to give us 6, yep. And now we have 7.5. I'm going to divide to work backwards to see if we get the same answer. No, we got 1.6 here. So the change on the top was 1.5. The change on the bottom is 1.6. So these are not similar. These are not similar solids. All right, go ahead and answer your essential question. How do we identify similar solids? And then go ahead and put your level of understanding out to the side. Where are you at with this? When you are finished, you can come on back to the Google Meet and ask for help if you need it, or you can go and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.